A lot of you have probably heard of something called global warming, which is sort of the idea that over the past 200 years, the Earth has slowly been getting warmer and warmer. And a lot of people don't think this is that bad of a problem, but these poor polar bears are losing their home, so I think we need to do something about this. Over the past couple of years, there's been a giant push on the renewable energy sources, especially solar panels. But I don't think this is the best approach, because solar panels are harnessing the waste energy of the sun, essentially. But I think we should just skip that and make our own sun, using fusion. Fusion works by taking two isotopes of hydrogen, generally deuterium and tritium, and smashing them together at really, really high speeds. This resulting fusing of ions creates a couple byproducts: a neutron, an isotope of helium, and a ton of energy. So how we calculate the amount of energy created is we use Einstein's formula, E equals mc squared. So if we assume the difference in mass is about 1 gram, which is not very much, it's about a ball like this size, and if we assume that's the amount of fuel we're using, the amount of energy produced through fusion would be 90 trillion joules. And that's a bit of a hard number for people to sort of understand, because no one really knows what a joule is. But a joule, 90 trillion joules is equal to 21,000 tons of TNT. Do you know what else is 21,000 tons of TNT? The Fat Man atomic bomb dropped on Nagasaki in 1945. So that means that a little ball of hydrogen this big would create literally the amount of power of the atomic bomb that devastated an entire city. So currently there are 2 companies in the world that are trying to use this power for good and create electricity. ITER, which is a combination of 35 different countries that are making a magnetic confinement fusion reactor in rural France. It was set to be the first fusion reactor ever to create more power than it takes to run. Because right now our fusion reactors aren't really very efficient because of the amount of power it takes to get helium, or hydrogen, to the temperature required for fusion. The second company is General Fusion, which is a Canadian-based company from British Columbia. They are making a magnetized target fusion reactor. This is cool because until a couple years ago, the magnetized target fusion was thought to be completely theoretical until the head of this company, Michael LaBerge, proved that it worked by making a small nuclear reactor. So you heard me mention now a couple times that our nuclear reactors right now aren't very efficient. And the reason this is because our method of getting energy from fusion is really bad. What we do is we use the plasma to heat up a hot fluid, generally heavy water or liquid sodium. We then pass this to a heat exchanger, which spins a turbine to create electricity. This is pretty bad because it's only 33 to 50% efficient. So we get a ton of energy, and then we barely create any from that. So when I saw this number, how small it is, I was pretty disappointed because we're not really unlocking the full potential of fusion energy. So I did some research into methods of getting energy from fusion, and I came across this thing called direct conversion. Direct conversion works by nearly directly converting fusion energy into electricity. So direct conversion is made up of 2 different parts: an electron collector and an ion collector. So how you can sort of think of this is there's a giant 9-volt battery. You have your negative terminal and your positive terminal. Your negative terminal is the electron collector, and your positive terminal is the ion collector. All you have to do is then plug in a wire to your ion collector and your into your electron collector, and then you have electricity. Simple as that. I'm just joking. It's not simple. But yeah. So the 2 major benefits of direct conversion is it's really, really small. You don't need a big reactor for it. And it is 90% efficient. That is way better than our current method of doing this. So to put this into perspective of how good this is, what you could do is you could divide the city of Toronto into 22 sections. In each of these sections, you could have a nuclear reactor the size of a desk, like just a box this big. And then from those, you would have enough power to power each of the section and more. So you could store excess power in batteries. So say nuclear reactor number 8 was to shut down. That section would not run out of power because it would have the batteries and the surrounding nuclear reactors to chip in so that there could never truly be a blackout. So the only way there could ever actually be a blackout in a major city such as Toronto was if for some reason every single reactor was to shut down, which is nearly impossible. So when I realized how big direct conversion can have, how big of an impact it can have, it could create a completely green with no harmful effects like grid to power major cities, I wanted to do something about this. So I decided to start a company. And the first thing I did was make an awesome logo. But then I realized that was a really bad idea, and I should prove this works first. So I decided to make a nuclear reactor in my garage. Yeah. So I decided to start off a little smaller than a nuclear reactor and make this. This machine makes plasma, which is the first step of achieving fusion. The problem is, even though this looks simple, you need really, really expensive equipment to make it. So right now I am researching, trying to find a lab that will let me use their equipment. But I really hope that one day I'll be able to make my dream of non-invasive power become a reality. Thank you.